This is OpenNMS 101, Module 13, Part C, Command Line Provisioning. In Part A of this module, provisioning was accomplished through discovery. There are two drawbacks to discovery. The IP to requisition relationship must be known ahead of time. That may be difficult to do. And a large network scan can take an inordinate period of time. In Part B, provisioning was accomplished through the GUI requisition. This method can be cumbersome when more than 10 nodes are involved. To remedy the issues of provisioning through discovery or the GUI interface, OpenNMS offers a couple of tools that can provision nodes from the command line. This is meant to work with an external system that can track what is available on a network. For example, a CMDB or a DNS system. Working from the command line also provides greater control over the provisioning process. All the OpenNMS admin requires from an external system is a file formatted to provide the FQDN and IP address of a node. The example demonstrates how each line would contain the FQDN and IP address. No commas are necessary. The OpenNMS admin then associates the FQDN with a requisition. If necessary, the OpenNMS admin may have to develop a new requisition. Creating a requisition or foreign source is beyond the scope of this module and requires a knowledge of how a group of devices, for example, Cisco routers, work. The provisioning process remains as it was in Part A. Verify the nodes in the DB and OpenNMS file system. Delete the nodes. Verify the nodes are deleted in the DB and OpenNMS file system. Add the new nodes. Verify the nodes are added in the DB and the OpenNMS file system. Back up the deleted nodes metric collection files. Verify services and collection on the added nodes. This is a tutorial provisioning working file. The first two columns would come from an external source, and the third column would be added by the OpenNMS admin. In this tutorial, the file provisioning_working_file.txt is kept in /temp. It is a straightforward text file. As a demo of how the text file will be used, apply the single line script to this file. The script will read three variables from the text file, H, I, and R. These represent the host, IP address, and requisition in each line. It will then print out each variable preceded by its meaning. Execute and note the output. There is nothing special about this file. The first command line requisition method uses the newSuspect event. Events have been covered since Module 3. The newSuspect event asks OpenNMS to provision a node based on an IP address. OpenNMS covers the newSuspect event in the Horizon Operation Deep Dive documentation under Provisioning, Directed Discovery, Add Nodes via newSuspect Events. In addition to adding the required IP address, OpenNMS recommends adding a foreign source parameter to the event. Verify the tutorial requisition nodes are in the OpenNMS DB and file system. The pg.sql script was covered in Part B. It lists the tutorial requisition nodes in the top table. Each node's IP address is in the second table, and the SNMP interfaces associated with each node are listed in the third table. From the etc/imports subdirectory, cat the contents of tutorial.xml. The 4 tutorial requisition nodes are in the file. Verify that the metric collection subdirectories exist for each node. SNMP/12 is for New York. SNMP/13 is for Denver. SNMP/14 is for New Orleans. SNMP/15 is for Sacramento. These will be backed up in a moment. From the requisition GUI, click on the button at the far right of the tutorial line and select Remove All Nodes. Confirm the deletion. Sync the requisition by clicking on the center button on the tutorial line and scanning all nodes, and then click on Synchronize button. Return to the command line. The metric collection subdirectories for the just deleted nodes are still in place. The nodes have been removed from tutorial.xml, and the tutorial requisition nodes no longer exist in the DB. Return to the command line and note that the single-line shell script has been changed to output the sendEvent.pl newSuspect command for each line in the provisioning working file. This command will not execute the sendEvent command. It will print it out. This is a good way to make sure of what will happen. 4 lines are printed. Note how this matches the template provided in the OpenNMS documentation. Copy and paste and execute each line. The first line adds 192.168.159.106 to the tutorial requisition in OpenNMS. Notice that the FQDN is missing. OpenNMS will figure that out. The second line adds 192.168.159.107 to the tutorial requisition in OpenNMS. In practice, OpenNMS should be able to ping the given address. The third line adds 192.168.159.108 to the tutorial requisition in OpenNMS. The PTR record for an IP should be available to OpenNMS. The fourth line adds 192.168.159.109 to the tutorial requisition in OpenNMS. Recall that SNMP authorization has already been configured for these IPs, so collection should begin as soon as possible. In the tutorial, OpenNMS added the nodes in short order as verified in the tutorial.xml file. The nodes are already in the DB. Note, sometimes it may take a bit of time to add nodes using the newSuspect event. It depends on the OpenNMS load and the number of newSuspect events being generated. Return to the GUI and select Info Nodes. Check on denver.localdomain. The node will require time to verify monitoring and begin metrics collection. Return to the console. A script /temp/backup was created to back up the deleted node metric collection directories. In Part A, this was done on the command line. That can be a bit clunky. Run /temp/backup. The OpenNMS SNMP metric collection subdirectory is clean. The OpenNMS SNMP backup directory structure is taking shape. Looking good. Note how appending the node IDs to the node labels will help sort the restoral process. It has been a few hours since the nodes were added. Beginning on the Denver local domain front page, the services are all up. Select Resource Graph and select all the tutorial indexes. Click on Graph Selection. Set the time period to last 2 hours. The graphs look good. Select Info Nodes. Click on neworleans.localdomain. The services are all up. Select Resource Graphs and select all the tutorial indexes. Click on Graph Selection. Set the time period to last 2 hours. The graphs look good. Select Info Nodes. Click on newyork.localdomain. The services are all up. Select Resource Graphs and select all the tutorial indexes. Click on Graph Selection. Set the time period to last 2 hours. The graphs look good. Select Info Nodes. Click on Sacramento.localdomain. The services are all up. Select Resource Graphs and select all the tutorial indexes. Click on Graph Selection. Set the time period to last 2 hours. The graphs look good. Provision.pl can be used to add nodes to an OpenNMS requisition. It can also be used to delete nodes from a requisition. It can be used to list all the nodes in a requisition. It can be used to set or change properties on a node. It can be used to add or remove services to or from a node. Provision.pl can do a lot of things. This video will use it to add nodes to an OpenNMS requisition. An overview of provision.pl can be found in the Horizon Operation Deep Dive documentation under Provisioning, Fine-Grained Provisioning using provision.pl. It is probable that a system may not be ready to run provision.pl. 2 Perl-related packages may not be installed: LWP and XML Twig. LWP is the Perl library for the World Wide Web. XML Twig is a Perl module for processing XML documents in tree mode. Try to install these Perl modules using the command given: dnf enable repo * install Perl LWP Perl XML Twig. DNF is the package manager for Rocky Linux. -- enable repo * tells DNF to look in all the available repositories, whether the repositories are enabled or not. Install tells DNF to install the packages that follow. There is a problem with the pg.dg-common-testing repository. Based on the author's experience, this repository can be ignored for the purposes at hand. Rename the repository, adding the suffix ignore. This should be undone once Perl LWP and Perl XML Twig are installed and provision.pl is working. Retry the dnf install command. Install the packages. There may be quite a number of supporting packages. The install should be ready to go. Try running provision.pl. What scrolls by is the help for provision.pl. This video will make use of the screenshots of that help. Provision.pl adds some complexity to the provisioning process, so the provisioning process will be slightly modified so that provisioning is performed at the end of the process as compared to occurring before the backup process. Verify the current nodes are in the OpenNMS file systems. cat tutorial.xml. 4 nodes are in this file. Check the OpenNMS DB. The 4 nodes, the appropriate IP interfaces, and SNMP interfaces are in the DB. Check the metric collection storage subdirectories. SNMP/16 is for Denver. SNMP/17 is for Sacramento. SNMP/18 is for New York. SNMP/19 is for New Orleans. Turn to the requisition GUI. Click on the button to the far right on the tutorial line and select Remove All Nodes. Confirm the deletion. Click on the tutorial line's center button to synchronize the requisitions. Scan all nodes and click on the Synchronize button. Return to the console. The nodes have been removed from tutorial.xml. The nodes are no longer in the DB. At this point, back up the metric collection subdirectories. The script is in a file named /temp/backup. This script moves the metric collection directories of the just deleted nodes from SNMP to backup/SNMP. Check SNMP. It is clean. Check backup/SNMP. It is clean. Provision.pl requires user authentication in order to work. This is done with the username and password arguments. Rather than include these arguments on the command line each time provision.pl is executed, store the information in the user's home directory under the directory .opennms in the file provision.plrc. In the Linux environment, the file provision.plrc only allows the user read-write privileges. No other user can access this file. The contents of the file are 2 Perl variable assignment lines, one for the username and one for the password. The effectiveness of the configuration can be tested by executing provision.pl requisition list self-monitor. This should display information about the self-monitor requisition. Take a moment to learn about the Linux uuid-gen command. uuid-gen creates a universally unique identifier that can reasonably be considered unique among all UUIDs created on the local system. This is going to help in the provisioning process. This is a repetitive run of uuid-gen. There are no repeat values. There are 4 steps to provisioning a single node using provision.pl. 1. Provision the node. The syntax is node, add, foreign source, foreign ID, node label. A sample line might be node, add, tutorial, the requisition /foreign source, a foreign ID created by uuid-gen, and the fqdn, denver.local domain. The foreign source and foreign ID must remain constant on a per-node basis. Note that in these samples, the foreign ID, or UUID, has been abbreviated for space. 2. Assign an IP to the node. The syntax is interface, add, foreign source, foreign ID, IP address. A sample line might be interface, add tutorial, the requisition /foreign source, a foreign ID created by uuid-gen, and the IP address, in this case 192.168.159.106. 3. Set the IP as the primary SNMP interface. The syntax is interface, set foreign source, foreign ID, IP address, SNMP-primary space P. A sample line might be interface, set tutorial, the requisition /foreign source, a foreign ID created by uuid-gen, the IP address 192.168.159.106, and SNMP-primary P. 4. Set the interface as managed. The syntax is interface set foreign source, foreign ID, IP address, status 1. A sample line might be interface set tutorial, the requisition / foreign source, a foreign ID created by UUID gen, the IP address 192.168.159.106, and status 1. The nodes are in pending state after provisioning. To get the nodes into the OpenNMS file system and DB, the requisition must be imported. The syntax is requisition import, foreign source, rescan existing, true. A sample line might be requisition import tutorial, rescan existing, true. Use the file provisioning_working_file.txt as before. This is a script to process that file and create the necessary provision.pl lines to add the nodes to OpenNMS. Note that the script assumes the presence and proper configuration of $home/.OpenNMS/provision.plrc. The bottom of the script indicates what provisioning_working_file.txt should look like. The file will be available in the module downloads. This file does nothing to OpenNMS. It only prints out the commands to be executed. Perform a test run to get an idea of provision_its output. 4 nodes will be added. As indicated in an earlier slide, each node addition has 4 steps. Add the node, add the IP, set the IP to SNMP-primary, and manage the IP. After the 4 nodes have been provisioned, import the requisition. Execute the script again, but this time send the output into a file. Cat the file, z_doit. Execute the file as a script. Look at the etc imports tutorial.xml file. 4 nodes are in that file. Recheck the OpenNMS DB. 4 nodes have been added to the tutorial requisition with the appropriate IP and SNMP interfaces. Return to the GUI and select Info Nodes. Click on Denver.localdomain. It will take time for the monitoring and collecting to show properly. It has been several hours since the nodes were added. Beginning on the Denver.localdomain front page, the services are all up. Select Resource Graphs and select all of the tutorial indexes. Click on Graph Selection. Set the time period to the last 8 hours. The graphs look good. Select Info Nodes. Click on NewOrleans.localdomain. The services are all up. Select Resource Graphs and select all the tutorial indexes. Click on Graph Selection. Set the time period to last 8 hours. The graphs look good. Select Info Nodes. Click on NewYork.localdomain. The services are all up. Select Resource Graphs and select all the tutorial indexes. Click on Graph Selection. Set the time period to last 8 hours. The graphs look good. Select Info Nodes. Click on Sacramento.localdomain. The services are all up. Select Resource Graphs and select all the tutorial indexes. Click on Graph Selection. Set the time period to last 8 hours. The graphs look good. 4 methods of provisioning nodes were covered in this module. Discovery has the advantage of direct scheduling within OpenNMS, but is dependent on being able to find a tie between requisitions and IPs, IP ranges, or URLs. Discovery can also be problematic when the address scan space is too large. Using the requisition GUI can be a bit cumbersome for more than 10 nodes at one time. There are 2 options from the command line, both of which would work well with a file containing rows with host, IP, and requisition information, both of which can be scheduled to run automatically. newSuspect is the simplest of the 2, but provision.pl has so many other purposes besides provisioning that it behooves the OpenNMS admin to learn how to use it.